Welcome to the analytics track, and today's session is MS degrees in analytics. We have 4 programs. I'm Mike Gorman, University of Dayton. I'm the president of the analytics section of Informs, and so I'm very excited and interested to hear what our distinguished panel has to share with us. We have Klabjan from Northwestern University. We have Helmut Schneider from LSU. We have Ken Gilbert from University of Tennessee, and Michael Rappa from NC State. Each of these schools have, in the recent past, developed a master's degree in analytics. The way we're going to structure today's meeting is rather informal. Each of our panelists will discuss briefly, maybe 5 minutes, an overview of their program. And I have a few questions prepared, but we really want questions from you. And so we hope to have a nice interactive session. So, choosing randomly, I'll go to my left, and we'll let Diego describe Northwestern's program first, and then we'll go down the line. Diego.
Right, so random is from left to right.
Well, you said random, so now you ordered
random algorithm there.
So at Northwestern, we are starting an MS in Analytics in the fall of 2012. So we are on quarter, so Northwestern is on quarter, so that's the fall quarter. It's going to be a full-time program with roughly 30 students, initially perhaps 20 students, but then we'll ramp it up to around 30 students. The targeted students are actually seniors in sort of adequate institutions, so those that are about to graduate, don't want to enter the workforce immediately and want to get sort of a more advanced degree, yet they don't want to enroll into a PhD program. So we are, marketing. We are focusing our marketing campaign towards, seniors at comparable, peer institutions. So it's going to be a 5-quarter program. So that means 15 months. There'll be 3 quarters, and then mandatory summer internship, and then they'll come back for 1 more quarter. So the subsequent. So fall, winter, spring, summer internship, and then winter. The summer internship will be a mandatory effort. Sort of, it will have to be an off-campus summer internship. And then in the subsequent fall quarter, they'll come back on campus and they'll take 2 more courses, and they'll take the capstone design project. The structure of the curriculum is approximately a third, which means a third sort of courses focused on IT, 1/3 on what I call data scientists or data scientific aspects, and 1/3 on the business side. So the students at the end, should be well trained in all 3 of the aspects that are present in analytics. I guess these are the main facts about our program.
Thanks, Diego. Helmut's going to tell us about Louisiana State.
Okay, to tell you about our program, I have to go a little bit into history. We are I'm at Louisiana State University. We are in the business school. Our department is called Information Systems and Decision Sciences, and we teach everything from information systems, statistics, operations research, operations management. So a year ago, we started thinking about an analytics program because we're kind of trying to follow what is going on, the demand in industry, what's going on at the professional organizations. And so at the same time, the dean of our college and the dean of agriculture, they came to me and said, well, Helmut, there is a great program in North Carolina, and Mike will tell you about it. So they went to North Carolina, and they urged me to visit there also. So we went and visited North Carolina, and we came back with an impression and said, well, this is a great program. Let's try to replicate that. And that's what we are trying to do. And we're learning in the process. There are some things Mike was able to pull off more easily than we were. And we can talk about that later in the presentation. But we are constrained by what faculty we have, what budgets we have, I can't hire new faculty, I can't pay faculty. So we are constrained. We nevertheless trying to do similar things. We created this 10-month program, and we have a pilot started this fall with 9 students. And we're learning a lot along the way, things that work and things that they don't work. But we like the modularized program, going away from a 3-hour class in statistics, 3-hour class in forecasting, 3-hour class in linear programming, and so on. And we like that what Mike was doing, just say, well, they may just need 1 hour linear programming. Why do they need 3-hour course but the way our classes are set up, they're all set up 3-hour classes. So you have to be a little bit creative to just do things and hope nobody notices in the administration. So you do a lot of things that if somebody in some committee would kind of find out, they probably would object to it and say, well, you have to first go through all the curriculum committees. So our program at the moment is still called ISDS program, but we are in the process of changing it to Masters of Science in Analytics. And I got that actually through the university, believe it or not, it's got through. It was a little bit tricky, and but it's at the Board of Supervisors, and then it has to go to the Board of Regents, and then hopefully next fall we are up and running with a Master of Science in Analytics, with kind of a 10-year program focusing on the most of the what analytics is.
Okay, thanks.
I'll tell you a little story that kind of illustrates what we're trying to do with our program. Our students in their last semester, which for our first class, this is their last semester, they'll graduate in December, they have to do a project, we call it their capstone project, with a client in government or industry. And this semester their client was this group that was wanting to start a charter boarding school in Knoxville, and it was going to be located on Knoxville College campus, which was a historically black campus. Some of you probably saw the movie Moneyball. They were trying to do something similar to the Seed School in DC. So that they came to us, and basically what they wanted our students to do was to do some predictive analytics. How many students in Knoxville are at risk and would benefit from that kind of learning environment? And so the students gathered the data and found, yeah, there's about 1,000 students in Knoxville that would benefit from having this kind of school. These are students that are, you would predict that they are probably not going to graduate from high school in their current circumstances. But our students did something that really made us proud. They went beyond that, and they said, well, you know, the real question is not how many are there. The real question is how many would actually come. So they said, we want to form some focus groups. So we gave them some money, and they did some focus groups. And they talked to these guardians and parents, and they would say, would you like your kid to go to a school where most kids that graduate go to college? Oh yeah. Would you like for them to go to a school where they're served 3 hot meals a day? Oh yeah. Would you like to have extended school hours? Oh yeah. Would you like to have small class size and all of this? And then they got down to the question, and would you like to put your child in a boarding school? And the answer was consistently, not my baby, not in a boarding school. And so they reported this back to our client, and the group that's forming the school says, you know, we're going to have to change our model here. And they actually literally changed from a boarding school concept to a school that doesn't start boarding until 10th grade, I believe it is. 6 through 9 would be non-boarding. And then they also found that this location on Knoxville College campus, what everybody thought would be, you know, a real positive was not a positive in the eyes of particularly the donors that they were going after, that this college had been struggling and its facilities were really in bad shape and everything, and potential donors would say, I really don't think it's a good idea. And so anyway, what I'm trying to illustrate is we're trying to develop students that know how to ask the right questions, and they know how to answer those questions with data and analysis, and then they know how to communicate the results they get in language that others can understand. And so we have created a program where we're housed in a college of business. We have our students take some courses in business. We of course teach them the technical content. We teach them communication skills, like I'm sure these other programs do. But we're trying to turn out a student that can really make a difference in the organizations that they're in. And we have a master's, MS degree. We also have a dual degree in which they get a master's degree and an MBA. It takes 2 full years with some double counting of credits and everything for them to get that. That's turned out to have some really attractive students in it. And then we also have an undergraduate degree. And our ambition is to, within a couple of years, be turning out a total of about 100 students in those 3 programs combined, probably 30 MS, 30 dual degree MS, MBA, and then the remainder with the undergraduates. And we have been selected as one of the strategic priorities in the College of Business, which means that's a little easier sell to the faculty. You're doing something that the college has put some resources behind. We're getting some positions. And at the same time, we're being held accountable for delivering on that. And so it's exciting and it's fun, and we know the timing is right. The jobs are there. Our recruiting strategy has been probably a little different from these other programs. We recruit the usual suspects, people with undergraduate technical degrees, but we also buy the mailing list from GMAT, the people who take the graduate business admissions or whatever and we look at that, and those who have taken the test but scored really high on the quant portion, we send them an email and say, you're going into business, you're really bright, you're good in math, let us tell you about a new career option here. And we are recruiting some of those people, and we actually have created a course that allow those people, if they didn't have enough calculus and things like that, and probability theory and statistics as undergrads, to transition into our program. And I've taken too much time. Go ahead, Michael.
Thanks, Ken.
Well, thank you. So I'm Michael Rappa. I'm the director of the Master of Science in Analytics degree program at North Carolina State University. We founded the program in 2000, formally approved by our Board of Governors in February of 2007, and have admitted students in a very intensive 10-month format program. We're now on our 5th cohort of students going through that 10-month cohort. We're currently configured to put through 40 students. We're growing next cycle, next June, to 80 students. So running 2 cohorts of 40 students. And what's interesting and different about our program is that we started the whole enterprise by creating an institute, the Institute for Advanced Analytics, and housing the degree program within that institute, and then placing that institute within the office of the provost, as opposed to one of the 10 colleges on campus. So we don't exist in the business school or the engineering school, agriculture school, like some of the other programs are participants in. The institute, essentially, the thought there was simply that we would create a kind of level playing field where faculty from any of the 65 constituent departments of the university, any of the 10 colleges, could participate in both developing the curriculum as well as delivering the curriculum. And it gave us a lot of freedom to really design the program from scratch, starting with a clean whiteboard and literally building the degree lecture by lecture from the ground up. Some of the important features of the program that I think make it different from what we might do in an MBA program, for example, or a traditional master's program is, first, in lieu of a master's thesis, we have a practicum project, which is a team-based project. In fact, the entire curriculum, from beginning to end, the students run through the curriculum as a cohort, working in teams the entire time. But there's one team, a practicum team, in which they're given data from a sponsoring organization under confidentiality agreement, and they go through a 7-month process of trying to understand the nature of the problem, cleaning up the data, doing the analysis, preparing a report and presentation to the sponsor. So practicum takes up a very significant core feature of the program, in which we then layer in a lot of the learning element around teamwork, leadership skills, communication skills, conflict resolution, all the kinds of things that you really need to be able to do a real-world project in the process. Other distinct features of the curriculum are we have a kind of strong partnership with SAS, in which we really want our students working with industry standard tools, things that employers know and use and value those skill sets in our students. And so we're fortunate to be situated close to SAS and be able to have a close partnership with them to make sure that we're using these kinds of tools that are actually used in the workplace. And I think that gives an important facet to the students. The other thing is, as I alluded to earlier, is we configure the whole program around teamwork. We do a lot of team building elements, including intensive peer review cycles throughout the entire 10-month sequence, in which we really try to develop students who are strong team players, as strong team players as they are in their quantitative skills. In addition, and somewhat related to that, we do spend very focused effort on communication skills as well. They go through some very intensive training to prepare them for giving presentations and really making that bridge between very complex analysis and how to share results with decision makers. And then finally, we really, in balancing the technical skill set that we're trying to give students, we also want them to come away with a sense of the context in which problems are being solved, and to really try to understand what's motivating the business, why something is a problem, and to get the students thinking beyond fitting regression equations or coming up with cluster models and things of that sort, to know that what it means to be an insurer or a bank or a retailer or an online business, and to add value into the process because you understand something about the business. So we admit through, as I say, about 40 students now, and about half of them are mathematics and statistics students. The other half are a spectrum from things like finance through to engineering subjects and other science subjects as well. We take in about 35% to 40% with advanced degrees already, including MBAs and PhDs through the curriculum. And the final point I would just make is that the program has been enormously successful for us. We have now, having graduated 4 classes, have essentially a 90% plus, this year was 97% plus placement rate by graduation. So the demand is very high for these students. I like to say that they are the most sought after and highest paid graduates of NC State. This past graduating class of 39 students had 90 companies interviewing them, of which 35 of those companies came to campus. The average student had 15 interviews. 3/4 of the class had 2 or more job offers. A third had 3 or more. And the salary ranges are very, very strong. So it's been very, very successful for us, and part of the reason why we're very happy to work with other schools as well to share some of the things that we're doing.
This is great. I have about 1 million questions. I wanted to ask all the panelists some really quick questions, fact-based questions, and some of you alluded to different components of your programs, but we didn't hear like that straight compare and contrast. So first of all, let's go back. When was the program started?
Fall 2012.
2012.
Well,
Future.
Well, we have a pilot going on right now.
Now. Okay, and then next
Then
year.
next year will be.
Ken?
Fall 2010.
2010.
And it's an 18-month program, so our first class is graduating this semester.
Very good. And
So we enrolled our first students in June 2007.
okay, very good. So these are really brand new. NC State's the grandfather, I guess. being
At 5
4 years
years.
old. Yeah. Okay. What school is the degree house?
Engineering.
Engineering.
Business.
Business.
We're in business, and we're kind of unique. We have the Department of Statistics combined with Management Science, and they're both housed in the College of Business.
But to add, we're working with the statistics department, which is in the ag school.
Okay.
So they provide 9 hours of classes.
I see. So
It's a combined, yeah.
It's across schools, and you have an institute.
So we exist independent of the 10 colleges, although we draw on a faculty from about a dozen departments in 6 of the colleges. Principally the College of Physical and Mathematical Sciences, which houses mathematics and statistics, College of Engineering, which houses computer science, industrial engineering, OR, and then the third the third college, it can be kind of surprising. We have people in, for example, our College of Natural Resources who do geographic information systems, and also we have people in textiles who do statistical quality control and things of that sort. So I guess the third college, 6 colleges, I'd actually be hard pressed to name all 6 colleges to remember. I think, let's see, you guys know? I don't know. Engineering, probably management is in there, PAMS, Physical Mathematical Sciences, textiles, management school, the College of Humanities and Social Sciences. So the only ones that aren't in there are like the School of Veterinary Medicine, I guess, and School of Education. But the thing is that we have this open format, so anyone can really participate.
Okay, and what department?
Industrial Engineering and Management Sciences.
Okay, IEMS, good.
Information systems and decision sciences.
IS and DSC.
We have statistics, operations, and management science, and our school, information management, is in the accounting department. That may change sometime in the future.
So I'm in the computer science department, and the 3 principal departments would be math, statistics, and computer science.
Very good.
Out of those 12.
I think all the programs were full-time? Good.
Ours is
I think they were all full-time. And how long does it take to get a master's and MS? I heard
15 months.
15, 10?
18 months for the MS. The dual degree MBA MS is 2 years.
Ours is 10 months.
Okay, so 10 months to 18 months. Good. How many credit hours is the MS degree composed of?
15.
15?
The whole program, 36 credit hours.
36?
Yeah.
Good.
I'm embarrassed to say I don't know, but it's somewhere in the neighborhood of 36 to 40 or something. Yeah.
And ours would be 30.
Okay. And the class format, is it the typical 3 credit hour courses, or are they?
I mean, for us, it's 1 credit is 1 class. So when I said 15 credit, that means 15 classes. 15
classes.
courses.
Okay.
15 courses.
Okay. And
Well, as I mentioned earlier, we have the 3-hour classes, but I have, for instance, Jim Van Scotter is a graduate advisor. He's teaching a course, but 3 different instructors. He's teaching 1 hour, then I have somebody from marketing coming in, and somebody from healthcare coming in teaching. So I'm trying to modularize the classes.
okay.
Yeah, we did it kind of by hook and crook too. Our computer software until this year wouldn't allow you to offer a half semester class, and so we'd take 1 class and chop it in 2 and have 2 topics in that class. But we're going to have some half semester classes, and we have entertained the idea of having block scheduling like NC State. We're not doing that right now, but we're thinking about. We think that might be a good idea also.
So we're sort of fully integrated curriculum, although to interface with the university, we essentially have 2 courses each semester, summer, fall, spring, And so the courses are sort of large holding blocks in which we do many other things within those blocks. So it's to kind of combat the problem of going down to half credit courses, which become really problematic. We just sort of said, why don't we go in the other direction and create really big courses, and then program faculty in those blocks creatively.
Okay, all right. I hear, I got so many questions. I'm trying to fast ones, and then we'll go to that. I heard a mix of topics from IT, data-centric topics, statistical, OR, prescriptive, and then I heard soft skills. Those are the 4 big areas that I heard. Can you apportion your programs roughly what % of each of those things? So we get a sense of emphasis?
Yeah, so I would reword, or I have my own terminology, right? So the soft skills, that's the business side. That's what I call it. So that's roughly 1/3 of the 15 courses will be sort of focusing kind of on the business side. IT 1/3, and I call it, you call it statistics and mathematics, operations research. That's what I would call, data science. Data science, that's the remaining 1/3.
Okay.
So roughly equal split.
Very good.
In ours, as I'm just looking at my notes, it's a little difficult to do this division because, for instance, marketing, he teaches actually statistics with marketing together. So we don't have a course in business. We have a course that relates marketing to statistical modeling. So we're trying to cover all topics that you can imagine that belong into analytics. And so it's really hard to chop them up because we're trying to integrate all those topics with real business applications. So you can't really, it's difficult to say how much is here and how much is there.
Okay.
So.
Abstain. Can you give it a shot?
I'll hedge a little bit too. Probably less than 25% of our curriculum is business courses. The remainder has a heavy dose of statistics and data mining and those kinds of things. Some management science and some the data management. But when you look at individual courses, you see an integration there. For example, a lot of like the very first statistics course, they start learning the data manipulation, the SQL, and all of that kind of stuff integrated into that course. And we try to teach a lot of the content in context of a business problem rather than just say, here's a technique, here's a problem, here's a case, here's data, we'll work it in context. And they do presentations and team projects in almost all of their classes. So that's sort of woven throughout the curriculum.
So it's a little hard for me to answer because it is a kind of fully integrated curriculum. I started off thinking, well, there's probably 50% sort of mathematical and statistical methods, 50% soft skills, and 50% programming, tool building. Because if you know our degree, it's really intensive.
Probably what the state is like.
It's really intensive. But seriously, I think 20% programming and tool skills, about 40% methodologies, crossing fields of math and statistics. So whether it's data mining, forecasting, other things of this sort of methodologies, and then the other 40% is a really fully integrated element of soft skills, but also problem-solving skills that go in parcel with their project through the process.
Makes sense. One last question, I'll open up to the crowd. Mike, obviously you've got a strong relationship with SAS. I didn't hear specific software tools from the other schools. Are there specific tools that you favor in this program? Or there?
Yeah, so we plan to, so our students when they graduate, they'll definitely be well trained in SAS as well as SPSS.
I see.
And we'll also use Tableau as part of the curriculum, not in sort of all of the courses, but so there will be sort of equal importance between SAS and SPSS.
Very good.
We are going to use SAS. One of our deans has a historical relationship with SAS. So SAS has kind of come in and promise some support. So we will use most of SaaS software.
Very good.
We use R, Tableau, but probably if you look at the whole curriculum, there's a bias towards SAS there. And the students are pretty strong in SAS by the time they get out.
Very good.
And that's what the people that hire them tell us is attractive.
All right, I've been selfish with my questions, and I know there's some questions out there, so please.
Also, Michael's response is always.
Oh yeah, well, I heard you answered that question earlier.
So, you know, our approach is that
Nobody
we
did
want
the job.
the faculty make the decision about what tools they need to effectively teach what they're doing. And the program simply insists on it being an industry standard tool. That is something that is used widely throughout industry. We have very long-standing, close relationship with SAS, so our campus is pretty well versed in SAS, and so it's very common for faculty to know it and use it. And as a result, our students really get quite a lot of skill building in SAS. Pretty much all of them will graduate with one or more certifications that they earn en route to their degree as a kind of option. And as I think Ken alluded to, employers really looking for those skills.
Good.
You know, they really value them quite a lot.
Let's open up the questions to the floor.
So, Mike asked you the question of what percentage of your teaching is related to the technical skills or sort of methodologies within those methods or the buckets of statistics, data mining, forecasting, et cetera. Can you give any estimate of how you break that out? That's the sort of high level question. And then secondly, how much hands-on OR or optimization do you teach? And I ask because it seems it's much harder to dabble in OR, and so I'm wondering how you go about teaching something like that.
So we have, let me start. So we have essentially just one optimization course, or sort of a course that, say, I would classify as being a typical OR related course, right? So that's out of okay, so I'm excluding now sort of electives because for us they cover verticals. So among the 15 courses, the optimization course is the only one that really kind of, say naturally fits into, for example, this conference here. So all of the, and now when I say this, I have to make a remark that predictive analytics, I don't really classify it as being, sort of a hardcore, say, operations research topic, right? So we have just one, in other words, we have just one sort of classical operations research course. So how do we, how I was able to, how am I able to come up with, kind of classification, all right, this is an IT course, this is, first of all, there isn't really a clear cut between some of the courses, right? So my estimate, a third is, it more comes kind of from the other way around, which is, what do I want the students to, what kind of, knowledge and expertise I want the students to have. And in my opinion, sort of equal importance to every one of those three components. And then sort of we build the curriculum from that perspective, so having that in mind, and then we laid out the courses, etc. And so the instructors will be steered sort of towards, the third. I'm not saying that every course will have to cover, third, but some of the courses will cover, both aspects, for example, and I'll coordinate, as to how much of which.
Any other panelists want
Well,
to take?
you have to maybe add what I've said earlier. There is a little bit, I can look at my notes. We have a 36-hour program, and our program will be collaboration between our program and the statistics department, which is the ag school. And the kind of relationship is they will provide 9 hours of classes. So their classes are naturally not as integrated with business as ours because their background. So they will be heavy on statistics, teaching introduction in SAS program. They will provide all this service because they have been a SAS shop. They have been using SAS for a long time. So those are the 9 hours. Then we have we teach our students some business intelligence along, so they learn anything from database, what warehousing, how do you develop a cube, and how do you develop reporting from it. So that's a 6-hour, 3-hour, and another 3-hour course sequence. So then we have, and part of it, I don't have the, as I mentioned earlier, I don't have the freedom. I have a lot of money that I can hire people from outside. So I have these constraints, and kind of, we all know about constraints. I have to deal with what I have. So I'm trying to find faculty that fit in. And I have a faculty, Yang Chang, who is an operations research guy. And he loves that stuff. So he's going to teach an overview of operations research, a 3-hour course. And he will do a marvelous job. He will teach everything from linear programming, integer programming, stochastic optimization. And he will do that in the last semester. So then I went out around the departments and I looked for other people in the college. And I actually found a marketing professor. He got so excited. He volunteers his time to teach a 1-hour course without pay because he's so excited about marketing analytics. So that's how I haven't found anybody in the finance department, which may tell you something. Nobody volunteers.
You can anybody to work for free.
Yeah. So, but you kind of see what we're trying to do, trying to create a program with what you have, not with what you wish to have. So, and then we have a 6-hour, 6 hours of the 36 hours are project. They kind of, the faculty who guides them through how do you handle a real world project, from the collecting the data to cleaning the data to modeling and eventually deploying something. So,
And is that with a real world client? A live
yeah,
client?
we
Field study?
the first semester in fall we just went through the principle of this CRISP methodology, and in spring they will have real from some companies. We created an advisory board from local companies, Blue Cross Blue Shield, some other healthcare companies, Medicis, and we have Coca-Cola, and we will have some projects from them.
Good. Sorry.
I think the biggest chunk of our curriculum involves the traditional statistics, or regression, multivariate, data mining, those kinds of things. The employers tell us consistently, but you've got to first get at the data before you can do anything with it. So we have quite a bit of SQL, R programming, Microsoft Access, and Excel, and all that kind of stuff. We don't have probably as much of the content as LSU would have in data warehousing and all of that part of it. We may need more, I don't know. On the your question about management science, our students all take pretty much the same core the first year, and that core has one 3-hour course, mostly LP. And then there's 2 tracks in the second year, and they can take electives, and one of the tracks involves taking the advanced mathematical programming, simulation, and the other things that we traditionally associate with management science. Not very many of our students have elected that track. The ones that do, or that have actually, some of them did so because they had undergraduate statistics majors, and they said, I want to broaden my skills a little bit. But they've gotten good jobs. So, there is a market for those kinds of students also.
Well, actually, I think your point is well taken, that OR, so there are master's degrees in OR, obviously, and there's a body of knowledge there that can be very challenging to master in a short period of time, given everything else that we're trying to do in the curriculum. I would probably estimate that OR, classical OR type topics, account for probably the equivalent of what would be a 3-credit-hour course woven throughout the curriculum. And what's, I think, really nice about our format is that we can evolve very quickly, though. So, we're listening to employers very closely, hearing what they say about our graduates that they employ, trying to understand if there are things in the skill set that need to be added, that we can add it very quickly to the curriculum. And I'm going to guess that we're going to see the amount of OR increasing from year to year. And that, as analytics begins to become much more diffuse throughout the various sectors of the economy, that OR will continue to point up. Now, I know that the OR people have this chart, where they like to be like in the sort of like the holy grail region of it, like you migrate up to OR. And I think there's actually some truth to that. So I'm not,
of course, hate that chart.
Yes, I know. I don't know who made that chart. But is there an author on that chart that says basically similar everywhere?
Somebody marketing the class.
Another question, please.
Yeah.
Either one. You go ahead.
Jem Saidam, UNC Charlotte. Welcome all. General Chair of this conference. Really appreciate it. A question about your business content. You mentioned there's business content. Would you elaborate on that, please? What portion and what's in the business content of your programs?
Yeah, our students take accounting. They take a course in marketing.
Managerial accounting, perhaps?
Managerial accounting. They take a course in marketing. They take a communications course which combines a whole bunch of different skills, but it's mostly writing and presentation skills, interviewing skills, those kinds of things. And all of those courses, as well as our own curriculum, involve the teamwork and the leadership skills and those kinds of things. Some of our students can elect to take a course in finance if they're interested in that.
They be standard finance elective, the MBAs take it and everybody else take it?
Yeah. And there's another big opportunity for these programs. We're meeting right now with the people from the finance department, and people who get an MS in finance or an MBA with a major in finance but have the ability to work with data get really good jobs now. We even saw that with our management science graduates before we created this program. The same is true in marketing. So we're working with those departments to create programs that combine some of our coursework with theirs to, at the end of the day, that's what gets you a success, is to create programs where there are jobs for the students that graduate.
So in my case, first I have to stress that the vast majority of our courses will actually be developed from scratch, right? So they are not existing courses, right? And this, I think we have only three existing courses. So only three existing courses. So all the remaining courses will have to be developed from scratch, right? Or are being developed from scratch. So there will be a course in marketing analytics, right? So which is going to cover, just that particular vertex, which clearly, it's sort of a marriage between the business side and the analytics side. We will also have a course purely devoted to the business aspects, which is, how do we find which analytics problem is sort of worth addressing, right? So, or, in other words, kind of have a positive, say, ROI, compelling case. How do you build your career in analytics? How do you visualize data, right? So how do you engage the business user from the very beginning of a project, etc. So there will be a complete standalone course, a course that's under the development that will focus on those particular aspects. So again, our students won't take our existing, say, MBA courses to, let's say, to cover the business aspects of analytics. all of them will be courses, tailored specifically for this MS in analytics.
We don't have business course per se. All the ones we have are in connection to what kind of consider topics. For instance, marketing analytics. That's a marketing professor. He's teaching kind of how analytics is used in marketing. I'm still looking for somebody in financial analytics, but I haven't found one. But we have somebody who teaches fraud detection who has been teaching kind of auditing and knows a lot about. So we're not teaching basic accounting, credits or debits. Our students don't learn that. So we're looking at topics. We have somebody who's teaching them about healthcare analytics, kind of what are the issues with healthcare data you have to know about before you touch healthcare data, because there's the civic laws, there are privacy issue, and all these things related to it. So in some way, we don't have business course per se. We have it there. We're trying to bring business in relation to the analytics topics.
So I would answer that quickly in the sense that, again, we have this sort of integrated curriculum, and it doesn't break out into individual courses in that way. But from a kind of architectural point of view, many of the things that might get classified into business courses really get integrated into the practicum experience itself. And so from a kind of design point of view, we're very big on kind of learning by doing, and then inserting a kind of knowledge enriching process while students are actually trying to work with data and solve problems, and giving them those sort of business skills, and I joke around a little bit, that we tend to make a course of everything, and so if employers say, boy, the students, they need more teamwork skills, our response is, well, someone's got to teach a course on teamwork. And so we don't do any of that. Instead, we just structure the students into teams and get them to learn about how to work into teams. And then the other thing is that just as the learning by doing element, we also really balance instruction with coaching. So I've become convinced that coaching is a highly effective learning mechanism, more than instruction where you have 40 students in the room, small groups, and not only coaching between the staff and the faculty and the student, but also and there's decades-long research on this, that students will learn as much, if not more, from each other than from instruction. So, given a particular situation where they're working on a team, and where their knowledge is asymmetric, where some students have very deep knowledge of data mining, let's say, and other students have deep knowledge of maybe marketing skills or whatever it might be, that they're able to, in a sense, learn from each other. So if you came to our program, you would see a lot of interaction between the students. And I should say that I guess if they were all 21-year-olds who just graduated from college, they wouldn't really have a lot necessarily to learn from each other, but our students range in age from 21 to 59. And so we have a portion of our population that has deep experience, and as well as people with advanced degrees in math and statistics and MBAs and so forth, so that when you put this group of students in a room working on specific problems, whether it's a practicum or whether it's a problem that one of their professors has given them to work on, they can really actually learn from each other quite a bit. But the coaching model is highly underutilized in universities, I think. And yet, we do it at the doctoral level, obviously, but we don't really do it at the master's level as much as we could. We do it a lot.
Let's take another question.
Yeah. Robert Dyson from University of Warwick in the UK. We have a program in the UK which is in its third intake, so we're not as old as you.
Yeah, I'm familiar with your program.
And a lot of what we do is very similar to what I'm hearing, so that's helpful. One thing I'm interested in, which I think is problematic, is how we assess it. I just wonder what patterns of assessment you use on your program.
Assessing the program or the students?
The student.
The students, yeah.
Yeah, no, the students assess the program all the time. So.
Yeah. Who wants to start there?
Well,
I might have the most experience
Yeah,
doing that.
Mike has the most experience probably.
So, you know,
Probably
we
the
have a
most.
very, you know, unorthodox format, but we rely on, so the key thing about our program is that we're not sort of blocked out into these sort of 10 3-credit-hour boxes called courses. And so we really evaluate the students programmatically, in a sense. That is, that their evaluations from the professors and also peer evaluations. We do peer evaluations extensively in 6-week cycles. And so the students are typically on 2 teams in any 6-week cycle. They're a practicum team and a study group team. And that would mean that they have upward of 8 team members across those 2 teams. And each team member will evaluate the rest of their team on 20 items, 20 scored items, as well as written comments. And all of the faculty evaluations and then all of the peer evaluations roll up to me. And then we sort of take that information and we're not so much focused on the more traditional summative evaluation, like you're an A, you're an A-, you're a B, but much more a kind of formative evaluation. So it's much more like, you know, we're running this program, the students are going through this very kind of tightly integrated 10-month process, and we want to take every 6 weeks measurements on what's going on, and those measurements are coming from the faculty, but also from this very elaborate peer evaluation process. And then we use that information, that whole set of metrics, we analyze the data backwards and forwards, how you're being evaluated by your team members, how you evaluate your team members, how the teams themselves overall form, and then we get about 60 pages of written comments from the students, because we talk with them very intensely about this is their responsibility, is to help their team members become better team players. It's not about judging them, but if they're doing something wrong, showing up late for meetings, or not being clear with their work, or not being a good communicator, or whatever it might be, whatever the issues are, that we want to actually act on that information. And we do that in every 6-week cycle. So it's a much more like, it's almost like a manufacturing process where you're running a line, you know, and the product is, you're trying to keep it within a certain spec.
Within tolerance.
Right? So that by the time it gets out, someone's going to want to buy that product.
What are the faculty evaluations?
So, you know, the faculty evaluations, so the faculty can do anything they want with the students. The students will already be formed into teams. So if the faculty wish, they could throw them problems as teams without worrying about having to organize them or any of those issues. But they could also give them individual exams, whatever it might be. But we ask the faculty a very simple thing. We give them a form with each of the students on it. And whatever it is that they gave them from an evaluative point of view, we simply ask them to identify the deviations from the mean. 1 or 2 standard deviations from the mean. So who is above or way above average, or who is below or way below average? The faculty love this. They hate parsing grades. And also the students, the faculty are not assigning direct grade. So the students have no basis of interaction with the professor around grading. It's all around what are we learning. And so, but the faculty, you know, I think a faculty member who's been around for a little while can walk into the room, and after some exercises, a test, or some interaction with the student, they can tell you pretty quickly, you know, how to red flag students who are not, you know, not understanding what you're doing, as well as the people who are very, very good.
Ahmed Jarrah, George Washington University. To me, one maybe great-grandfather of this might be Colorado State University with their engineering management program. And it tends to be pretty thorough. I mean, it covers all the aspects of business analytics. And it's an old program. It's been around for 15 years. But my question is, in their case, they have strong prerequisites. So you have to have linear algebra, sequence of calculus before being admitted. And then they give them very thorough coverage of and hands-on training. Do you think such prerequisites should, and they place their students in top places, and they're very popular graduates. Do you think such prerequisites should be enforced, and what's your view on that?
Go ahead.
Right, so we will, we do have, let's say, relatively strong prerequisites. So we're not going to admit, a student who doesn't have basic training in calculus and probability, etc. So we don't really have, any kind of 101 type courses, because they'll all have the BS degree in related, closely say related field. So I don't foresee that being a problem in a sense, and also the courses in the first quarter, they're not really hardcore, say, statistics related courses. They are a little bit easier than the remaining courses. Easier sort of in terms of the actual content, but still they're not, basic courses. So that's our approach.
Our thinking has evolved quite a bit on that. We sort of came from 2 master's degrees, one in management science and one in statistics, that basically assumed that you had an undergraduate technical degree. And there was a young woman that contacted me and came to talk to me about our program, and she worked at a local bank there in Knoxville. And she had a law degree. And she says, I'm really into this business analytics, and my sister and I intend to form a consulting firm one of these days doing this stuff. And she said, the first bank in Knoxville that figures out which customers are profitable and which ones are not is going to make some serious money. And so she was so enthusiastic and everything, and then we started talking about her background, and she was not hesitant at all about going back and taking all the courses she needed to be admitted into our program. But I said, well, how much math did you actually have in college? And she said, none. And I said, you didn't have any at all? She said, no, I AP'd out of all of the math I would have had to take in high school. And it turned out she had also made really high scores on her quant exams. And I thought, we're putting this hurdle of going back and taking 2 years of calculus in front of the very student that we want there. And so that was what caused us to say, let's create this 1 semester course that it's a 5-hour course, and we try to cram in all the matrix theory and all of the probability theory and everything that it's a pretty intense course, but if you're willing to go through that, then you're ready to hit the ground with the other students. And that seems to be working. And it's, if you go the other way, there's the opposite problem. You may have somebody that's really, really good quantitatively, but is never going to build the other skills that they need to function well in an organization. So anyway, we sort of have a hybrid model of getting students from both of those tracks.
So we have prerequisites, and I think our experience is similar in that you get some pretty interesting potential candidates who aren't necessarily math or statistics majors as you might want them to be. And so what we've done is we teach essentially the entire body of undergraduate statistics in a primer before students begin the program. And they can test out of it, so if they've already have a substantial amount of math and statistics, they can pass through it. But that we found teaching it very effectively actually works really well, because there might be somebody, say, with a statistics degree from 10 years ago, they've been out working out in industry, and they really need to be really focused again on the concepts, getting back into things. So, but we also have certain prerequisite requirements, and we're actually beginning to develop online versions of those prerequisites so that people can take them in the year or two before potentially being admitted from the program. Because I think, as Ken said, there is this issue that there are people out in the workforce who really would benefit from this education, but are kind of a few years out from school, didn't necessarily have the coursework in school, but now are highly motivated to take it. And we see students with, we're able to get students who've had the minimal prerequisites up to a very solid level of math and statistics through the intensity of our program. in a relatively short time. And that relying on just majors in those programs would be very limiting, actually, for us.
We are trying to recruit from engineering programs, math and statistics, but we don't have a long history. So based on the first class of the 9 students, actually those who do best are those, there are 2 students who had work experience and they had work in a related area. Part of it is just work ethics, how you work. You know how to work when you have worked for a while. And that program is so compressed that one student who kind of has a decent background, but he's used to studying 2 days before the exam, he says. And that's the way. And that just doesn't work in a compressed program. And so it turns out that maybe the students that have work experience and have worked in any field probably will excel in that program the most, regardless of the kind of prerequisite or what they have.
Other questions? Yes.
Hi, I'm Tim Hopper. I'm an operations research grad student at NC State. So if you look online with sort of the buzz of data science, analytics, and things, the people who are making a lot of noise about that online, they're thinking about tools from a different way than people have previously. And no offense to anyone from SAS sitting right behind me, but people aren't talking about SAS. They're talking about using open source things like R and Python and harnessing very recent tools like Hadoop and things. Are employers looking for these, or the people that use them just make lots of noise? And are you working towards teaching some of these more recently used skills to address these kind of problems?
So we have a course, Big Data Analytics, which is going to cover exactly, unstructured sort of NoSQL type data, and probably there will be no SAS in that course. To address your first question, are the companies looking for that? Absolutely. So if you have, from my interactions with industry, if you have expertise in Hadoop, you'll get sort of many offers from it, especially in the Silicon Valley area. So it is definitely a hot area, and so I attended a couple of predictive analytics conventions in the last month and a half, and probably half of the talks were around big data and unstructured data.
Yeah, I would second that. Really what you're saying is the things that are happening out there in the real world are just going exponentially, and academia tends to move at best in a linear fashion. So we just hired somebody who's into she was formerly with Google, and there's so much data that's not in the company's data warehouse. It's coming from all these social networks and things, and the way you analyze that data and work with it is quite different. And lots of times it combines the tools of management science and statistics. For example, if you're looking at communication patterns in networks, you'll be looking for clicks in networks. There's a new field I just learned about, Bayesian networks, that seems to be hot nowadays. So yeah, there's a lot of new stuff, that's new software that's happening really fast out there, and I don't know how in the world we're going to keep up with it, but that's what's going to be expected.
So I think it's an interesting question, and so we're very much in tune again with wanting our students to have the skills that employers need out there. And I think that some of the things that you're talking about are very West Coast centric. They're very sort of internet based, Facebook, LinkedIn, Google, things that sort of where they're dealing with very large amounts of relatively unstructured data sort of streaming off of the web. And that's a particular class of problems. I would say that in many ways that they're sort of still migrating up a kind of analytical progression. And what I mean by that is that most of the people using these tools are actually computer science people. And they're not actually really good data modelers. They're not necessarily sort of trained in the same way that people who come up through math and statistics are trained in approaching these problems. And so that their approach to things and the problems that they're trying to solve fit a certain kind of computational class. Recommending systems is a very common one, for example, but looking at link associations and other sorts of things. And I think there's a lot more room for them to progress, and that a lot of these other kinds of tools which are found throughout industry for doing complex analysis are really going to kind of converge with those as well. But it's an interesting area. It's certainly something that we want to pay attention to and understand.
I second Mike. I think that is, I looked around on the web too, and I've read lots of blogs about big data, and one blog suggested we need a new degree program called data engineer. And so, but it looked to me although there are more computer science related issues. So we're just starting our program, so we're not concentrating on computer science that much, so we're more kind of, we're trying to answer business problems and not so much big data problems. There's a real marketing problem and somebody wants to have this solved, or financial problem, or a healthcare issue, and we're trying to answer those, trying to teach the students how to answer those questions.
There's a little bit of an East Coast, West Coast thing going on there too. So, on the East Coast you have banks, pharmaceuticals, and businesses that have been going on for decades on very large scale, complex data analysis. In the West Coast you have mostly computer science people, streaming in and out, computer science, computer engineering streaming out of Silicon Valley, and the way they approach data and also the nature of their data problem is very particular in a way, and to me is still relatively immature in terms of how they approach things, and that what they really need is some of the more sort of disciplined and classical knowledge around data modeling, around statistics, a little bit more of the East Coast thing going on the West Coast. And we can learn from them too, but I think they have a very skewed element to them.
But can I make a remark? So yeah, there is a sort of a disconnect between East and West Coast. Okay? But East Coast now, financial institutions they are also using Hadoop, etc. For just because of the amount of data, it's not really streaming. Well, it is actually streaming as well. And the problem with big data is, or with Hadoop, Cassandra, etc. is you have to be an IT guru to be able to use them. That's definitely the fact. But I definitely disagree that it's being driven by, well, maybe it is driven by social networking, okay, but it's definitely expanding in other verticals, pretty, in a pretty quick pace. Telcos are using, are started to using big data, and now pretty much, every large corporation now has some components that is stored in big data. I mean, in big data, so I should say unstructured, non-SQL database.
Let's take another question in the back, then.
Hi, I'm Monica Gilbert. I have a quick question. So, you can correct me if I'm wrong, but my understanding is that one can look at business analytics from the methodology itself, and as you teach the fundamentals of, for example, any methodology, data mining or rule mining. And the other part is about training students to be competent enough to be using it in their workplace. A problem that we often face is, how do we get them these real data sets or the real feel for solving the problem, which often lacks when we teach it in like a course environment. How do you guys address that in your courses for different methodologies?
So let me again start the debate. So I'll be teaching in the winter quarter a course in analytics. That's kind of going to be it's going to be a rehearsal to one of the regular courses in analytics, even though it's going to be for undergrads. So I am using my industry connections. I will be getting, or I am actually getting, 3 real world data sets with millions of rows and several columns. So the students will definitely be exposed with not toy data sets, but with real world data sets. There are clearly challenges, right? In the sense of you have to mask the data, because I'll try to avoid, or at least initially, I'm not going to let students sort of engage in any NDA type agreements. So there are definitely challenges, and then where who's going to house the data? Okay, it's going to be internal within Northwestern, or it's going to be, say, the company side, and students will have remote access. But it's from my path, from my research experience, dealing with toy problems is very, very different from dealing with the real world problem.
And what software do you use, SAS?
Yeah, for in this particular course, we'll use SAS, and the database might actually be provided by a commercial vendor of databases. So far, I cannot name that vendor, but most likely.
We have an advisory board, and we approach some of the companies and to provide some data, and some do it, stripping out confidential information. Also, on another job, I'm running a highway safety research group, and we have all the crashes. It's a huge database with 2 million records over 5 years, so we have lots of information. We also use kind of to train the students in dealing with real dirty data, because if you have ever seen a police report, you really know what dirty data is. And so they can learn from those basic data sets how kind of what they have to go through.
There are a lot of data sets available. These would not fall under the classification of big data or necessarily as messy as most real-world data sets, but we have gone to SAS and taken their business analytics 1-week course. They provide you lots of good examples and data sets to go with them there. There's a company named dunnhumby that's the Kroger joint venture that does all of the customer loyalty program analysis. They put some of their data sets on their website that you can download if you want to do market basket analysis and those kinds of things. And then some of our classes work with a client that's maybe doing a Google AdWords campaign, so they get lots of data from them on that. And other than that, it's finding a client that's willing to share the data with you. And that usually gets to be kind of constrained. They're worried about confidentiality and things like that.
So with our program, real data is really at the core of the program. So the practicum process, which stretches over 7 of the 10 months, the students are structured into 5-person teams and given data from a sponsoring organization, typically anywhere from hundreds of megabytes to hundreds of gigabytes of data. It can be structured, unstructured. It could be a SAS data set, or it could be just data streaming off of the web, all done under non-disclosure agreements between the student team and the sponsor. And it's sort of a central feature of the program. I think it is an enormously important learning experience for the students to actually work with real data and all of the problems that attend to working on a real problem with that kind of data. And but it's a challenge to do. So we put out a call for proposals each late spring, and we have typically gotten about 30 or so proposals, of which we are able to select 8 projects. Next year we'll actually be increasing that to 16 projects. But it's a very complicated process, and it requires a lot of effort and management from a programmatic point of view. It's not something you can do in a 15-week course. This is something that literally spans the length of the program, and yet it's absolutely key, I think, to the success of the students in the program. So it's worth the effort.
If you really want to make it interesting, let them work with a startup company like this charter school. They have to go out and find the sources of data, census data, police data, data from the school board, and try to put it all together and make sense of it. And it's a different problem from the big data problem, but it's a problem, and it's a real good educational experience.
Dirk.
My name is Dayton from Ghent University. I've been involved in 3 programs until now that deal with analytics. We started one 13 years ago, Master of Science in Marketing Analysis. The other one 8 years ago, Master of Statistical Data Analysis, which is more towards the statistical area. And finally, a Master of Business Engineering / Marketing Engineering, which is again more marketing, but includes the OR side. So we actually have the different compositions, I think, in-house. What we notice, and I want to come back to the software issue, in 2 of them, they are SAS and MATLAB as being used. Whereas in the statistical data analysis, we teach R and SAS. The interesting thing is we have been running that one for 8 years. And if we take a look at the graduates, what do they do actually afterwards? More than half of them have become SAS programmers. And of the other half, 25% are actively using SAS and no other software. So and this is a European context, of course, so I don't know to what extent it generalizes, but in our experience, it has been that the open source has been growing, admittedly, but it's still negligible in the marketplace. And one of the key things there is that open source is great for analysis, but what in terms of data preparation? There, if you want to use R successfully, up till now, you had to resort to actually using SQL to do data pre-processing, or some form of SQL. And this has been rather difficult, and the students struggle with that part. Whereas if you move them to SAS, it has the great advantage of doing everything in the same package. The data pre-processing is very powerful, also with huge data sets, and also the analysis. So I think that's one of the reasons in the marketplace that SAS has been so successful and continues to be so successful. The competition hasn't learned that 80% of the time is being spent in the data pre-processing. And if we only teach students to do the last part, that wouldn't be fair to them, because in their careers, what will they have to be doing? The first things they will have to do is do the data pre-processing. Because that's the least fun part. Let's be honest.
A course in data scrubbing.
But I teach a sort of undergraduate courses based on projects, and I give them my own data, right? It comes from airlines. What I do is I deliberately actually delete some fields or replace some numbers with characters, and then I give the data to the students, and then clearly they come back. Well, how can the fare be X? And I mean really letter X. All right, because what I want to convey to the students is data is always dirty. You'll spend a substantial amount of time cleaning the data. Now R versus SAS, so my comment, and that's observation by working with companies, and probably SAS is aware of it. Okay, so when I work with an S&B company, so small and medium-sized business, that doesn't yet have an agreement with SAS, or in other words, a license with SAS, and I tell them, all right, you'll pay X for SAS, or we can do it in R with no license. Well, guess what they pick? I mean, they go with R, clearly, right? I mean, okay, so who does the data cleansing? Well, we do it, right? I mean, so it has to be done, quote, manually. So in other words, the ETL process, it has to be done, quote, manually.
And which environment do you use to do that?
What do you mean, development environment? So, or
yeah.
what are
do you do that in R then, specifically?
Do what now? The data
If
cleansing?
the data cleansing.
No, usually it's done outside of R.
In C.
So we usually, I mean, because we typically embed R within whatever is the requirement of the company, right? So if a company is a Microsoft shop, we do it in .NET. If the company is a, say, Unix, we do it sort of in C++ or whatever. And so we call, R within that particular language, and the data cleansing, etc., is done at a programming level.
I was at a conference last year where somebody in the audience, after the discussion, stood up, and he was from the company, and said, well, you at the university, you should teach everything, every software. You should teach SAS, SPSS, ARM. He went on, has this long list. Well, our view is we don't teach software. We don't want to do that really. That's not an academic program to teach software. We want to have it as easy as possible to show them the methods. And so the reason we are using SAS, because it's simply easy. We are getting support from SAS and students learning the methods. Now, if they go out and don't have SAS, they have to learn on their own. They should be able to learn another software pretty quickly. But teaching all these softwares or using multiple different softwares, I think that would kind of put an additional burden on and take away from all the other things we try to get through.
We have a business analytics forum where companies come together to share best practices. Companies like State Farm and Capital One and Dunnhumby and so forth. And we actually had a panel discussion sort of like this one, talking about this issue. And there were sort of two opinions here. One, I believe, was Dunnhumby says, we're a SAS shop, we use SAS, but we don't necessarily expect you to know SAS when you come here. We just want you to know. But others said, well, we use SAS, and we'd prefer that you already know SAS when you come here. So it's sort of two different answers you're getting there.
Well, I think we think that tool skills are very important, and I think what Helmut alluded to is I think it's common on every campus. That we don't want to spend a lot of time teaching tools, and yet I'm not sure how the students are supposed to learn them. So that's kind of just one of those academic things, one of those academic culture things. So the way we handle that is that we don't want the professors teaching tools. So what we do is handle tool skills programmatically, as opposed to in the classroom between the professor and the student. We want the student already know how to use the tool that the professor needs in order to do logistic regression or to do data mining or whatever it might be. And so we do that very intensively in a very short period of time, in 6 weeks during the summertime, before they really get into the rest of the curriculum. But we very strongly believe that employers value tool skills. They have tools that they use, that they would much prefer students who use tools. And I would add, and I wish we've started surveying our alumni, but I can't really put very specific data around this particular question yet. But I would say that most of our students, although become very adept at SAS, don't necessarily get drawn into careers as SAS programmers. Right. That their knowledge of SAS is extremely important, is a key reason for why they're hired. They're going to companies that rely in, day out on SAS tools, but their knowledge of SAS really helps them really get into leadership realms and team leading realms and so forth, where they have to work with people who've maybe spent their career programming SAS and know it inside out, and that our students' knowledge of SAS gives them enormous credibility working in those team environments, and of course the ability to do things in SAS themselves. But I think that's true with many subjects. That this is the sort of long-standing problem with MBA programs. You train this sort of MBA student to go in to an organization with very little technical knowledge or depth of technical technical knowledge, and they're supposed to lead a team of these technical people who sort of say, well, who is this guy? He doesn't know anything, you know. I mean, it doesn't really work very well. You know, that creating leaders who are in fact steeped in the knowledge of the tools and methodologies and so forth that their businesses are built around is really, in my mind, my bias, is really the right prescription for educating people who can ascend to leadership positions in those organizations. So.
There's a related issue to that, is the certification issue. Particularly with our undergrads, we could guarantee them a job with a SAS certification or with a Google Analytics certification. And, you know, part of you says, well, that's what you ought to do. And the other part, well, we don't want to get into the business of training SAS programmers or Google AdWords experts. We want to train them to grow through the ranks of management when they get on the job. And so we haven't really resolved that issue ourselves, but that's an important discussion.
I think we have time for one more question if we have another question out there.
I don't know.
Please.
So I do operations research, which is, I mean, obviously operations research is suddenly claiming this field of analytics as its own in some ways. And for example, you go into the exhibit hall and there's lots of exhibits on predictive analytics and data mining and things. I mean, in my experience as a student at NC State, that's not a part of operations research. So at least in our curriculum, I mean, I'm interested in these things that I'm teaching myself. I don't think so. But how can these programs like these maybe play back into operations research and thinking about how, I mean, a lot of these skills that you're mentioning are things that I wish I was learning too, and it would be very valuable, but can then these work backwards?
So, there's this survey that Informs did where they surveyed the membership and they asked the members, like, is analytics part of OR? Is OR part of analytics? Or do they have any relationship with each other? And I think that the whole membership was split between the three categories. Yeah. 1/3 believes that it's OR is part of analytics, 1/3 believes analytics is part of OR, and the others don't think they're associated at all, or will overlap.
The other third said they overlap somewhat. And there was actually about 10% split evenly, about 5 and 5, where 5 said they were completely unrelated, and the other 5% said they were exactly the same thing. So we were completely divided as an organization on what is analytics. And
no one abstained. No. Well, I think that analytics is a broad umbrella, and that OR is really a piece of how we're trying to at least cast analytics out there, and that we would love someone like yourself with analytics skills to come through with OR skills to come through an analytics degree, perhaps especially, or to double major in OR and analytics, or any of a number of things going forward. But I don't think it's going to not sort itself out real fast. I think there's going to be a few years of trying to figure out the relationship between these two sort of. I don't even want to call it, OR is definitely a field. I don't want to call analytics a field. I sort of tend to, when I say sort of analytics, I tend to look at the analog as a very sort of much more quantitatively focused MBA type education, as opposed to a discipline. MBA is not a discipline. MBA is like a kind of grab bag of skills across marketing and finance and operations and so forth. And I think analytics is usefully juxtaposed with an MBA as a kind of sort of set of skills that go across a wide range that produce a professional education. And that OR is really is a kind of field of science, if you will. It's a defined, very highly defined body of knowledge that one can master and typically goes on and gets PhDs in, typically, and a set of skills that can be applied. But that analytics would do well to really represent a kind of professional designation as opposed to a disciplinary field designation. Yeah, that's just my bias.
Yeah, I mean, I'd add to that, I mean, OR started off as what you want analytics to be these days, right? Namely, it's a professional endeavor, but became a part of a university, and university was liberal
And we
arts,
killed
which
it.
trains you to be good thinking citizens and not necessarily preparing for the workforce in all areas of learning. And OR sort of now, a master's in OR is somewhere in the middle.
Yeah.
It prepares you somewhat for the outside world, but in some ways it's like a liberal arts program.
So the universities have a tendency to making everything very academic. And I think after 50 years we did that with OR. Did it take that long? I don't know.
Well, it is interesting when you go to other conferences. I think I'm the chairman of a department that ranges from statistics to IS. I go to the AMSIS and I go to the statistic conference, and they talk about analytics there too. So it's not only talked about at Inform. So the statistical organization, they have actually going to have an analytics conference in spring, in February.
They're calling it a practice conference.
Yeah,
so they're being very careful about what they call it.
Yeah, but it's basically when you look at it, it's all analytics. So I think it's going to be claimed by a lot of different organizations.
So I'll put a different perspective. Okay, so I don't care how you call it. Okay? You can call it bananas or apples or whatever. To me, it's all what sells better, right? If I talk to VPs or about a project and I said that my expertise in operations research, they're like, what? What's that? If I tell them that I'm expert in analytics, they all understand. They, immediately we can start talking the same language. So, just from the sales perspective, analytics is definitely much more, say, entrenched in the business work, right? It's the scholarly work, that's kind of a different.
So I
that's
agree,
a fairy tale.
I agree with Diego on that, but a lot of people will sort of say, oh, well, this is just all about marketing, and that's where I would say, no, it's not all about marketing. It really is a way of defining a kind of body of knowledge in a different way than we might otherwise. But I kind of agree with you. We don't have to spend hours and hours and hours parsing out what OR is versus analytics, because it really doesn't matter at the end of the day. But you do get that sort of like, oh, this is just packaging. This is just marketing and packaging, and I think that's really missing the point.
There is, if we go back to the sort of curriculum, okay, so I am faced with a dilemma, and I don't have an answer, which is so we have a fairly big, say, PhD population in operations research. And I started getting requests. Okay, so will our students be able to take the MS Analytics courses, right? And now it's getting even worse because students from mechanical engineering and electrical engineering are coming with the same requests. And I don't have an answer. I don't know how I'm going to deal with that. I don't want them to take the MS Analytics courses, but I can't just close it for outside students. So